Hey guys, and welcome to Intro to Normal Distribution. So to start off, a distribution is just a different way to spread out data, and data can be distributed in different kinds of ways. And we looked at uniform distributions, we've looked at binomial distributions, so this is just a different type of distribution. So just like all these distributions kind of have different shapes to them. Well, the normal distribution, the one that we're going to look at, has a very specific bell curve or a bell shape. So this is the normal distribution where all the concentrated of data is going to be in the center, and then it kind of weans off both to the left and the right. So normal distributions are shaped like a bell. Some examples of normal distributions, so things that follow a normal distribution, are heights of people. So if we took the heights of everybody in this room and put it in a histogram, we would get a bell curve and also normal distribution. Size of things produced by machines, errors in measurement, blood pressure, and test scores. So if we looked at everybody's test scores and we lined them up, same thing, we would get that bell curve or a normal distribution. So normal distributions are used for many, many things. Some properties for normal distribution. The mean equals the median, which equals the mode. So our three kind of popular things that we do in data where we take the mean, the median, the mode, these guys are all equal in a normal distribution. The next thing is there's symmetry about the center. So if we look here, so here's the middle. The middle of our bell curve is the mean, the median, and the mode. They're all the same. It's the dead center. 50% of our data is contained to the left and 50% of our data is contained to the right. So there is exact symmetry, which means if, let's say this value here was 5, if this value here is 13, then this value over here, which is the exact mirror image just on this other side, well, from here to here I went 8, which means from here to here I would go -8, because again, exact mirror image, so which means that point would be at -3. So the symmetry comes into play all the time, but that's the big key here, is there's always symmetry about the center. Then 50% of the values are less than the mean, and 50% of the values are greater than the mean. Again, perfect mirror image. Standard deviation comes back into play. So what is the standard deviation? It's a measure of how spread out the numbers are. So if we look here, so these are our rules for our normal distribution. 68% of the values are within 1 standard deviation of the mean. So +1 standard deviation to the right, -1 standard deviation to the left. 68% of all the data is contained within 1 standard deviation left, 1 standard deviation right. And then there's the 95% rule, which is 95% of values are contained within 2 standard deviations. So here's the mean. So there's our mu for mean. There's our mean. 2 standard deviations to the right and 2 standard deviations to the left. 95% of all the data is contained in there. And then the 99.7 rule. So 99.7% of all the data is contained within 3 standard deviations to the right and 3 standard deviations to the left, which is basically almost all of the data is contained within 3 standard deviations. So depending on your standard deviation, if your standard deviations are small, then you'll have a bell curve that kind of looks like that, or really narrow. If your standard deviations are large, that's when your bell curve is a little more kind of flat and molehilly. So small standard deviation creates a really narrow curve. Longer standard deviations create a wider curve. So it's a measure of how spread out the numbers are. Think of it as how spread out your bell curve is. So as a recap, why do we need to know the standard deviation? Because any value is likely to be within 1 standard deviation of the mean, either to the right or to the left. It's very likely to be within 2 standard deviations in the mean, and it's almost certainly, like we can say almost without a doubt, even though we have that 0.03%, that it's going to be within 3 standard deviations. So standard deviations kind of tell us how likely we are to have a data point within there. So recap, just a different way. So the normal distribution, it's a bell-shaped curve, which looks like this. It's symmetrical around the mean. The mean, median, mode all have the same value. So this line here is the mean, it's the median, and it's the mode. The total area under the curve is 1 or 100%, as always with all distributions. 50% of the area is to the left, and 50% of the area is to the right. So 50% to the left, 50% of the right. Okay, what else? Approximately 68% of the area is within 1 standard deviation of the mean. So 1 standard deviation left, 1 standard deviation right. Remember, this dotted line is the mean. And so whatever the mean is minus the standard deviation, that would be that mark. So for instance, if the mean is equal to 5 and we have a standard deviation equal to 2, then this down here would be 5 minus 2, so this mark here would be at a 3. Okay, so if we fill in kind of our example, the mean is 5, standard deviation is 2, so 1 standard deviation to the left, that would mean that would be a 3. 1 standard deviation to the right, which would be that line there, standard deviations are 2, so we would add 2, so that would be at a 7. And our rule says approximately 68% of the area is within 1 standard deviation. So 68% of our data then is going to be contained within the interval from 3 to 7. Because that is 1 standard deviation left of the mean and 1 standard deviation right of the mean. Okay, what else? So 68% is there. Let me maybe move my little mean guy. Mean right there. Okay, so what else? Approximately 95% of the area is within 2 standard deviations of the mean. Okay, so if we go another standard deviation to the left and another standard deviation to the right, so it would be mu minus 2 standard deviations. So mu is 5. 5 minus 2 got us 3 minus another 2, so that's going to be 1. That's the mean minus 2 standard deviations. To the right, let's see, mu is 5. Plus 1 standard deviation is 7, plus another standard deviation, that would give us a 9. So this other line right here, which is 2 standard deviations to the right, would be a 9. Okay. And so 95% of the area is contained within 2 standard deviations of the mean. So in our example, 95% of the data is contained between 1 and 9 for us, for our very hard example. Okay, and then 99%, oh, let me move these guys again. So again, we're dealing with a mean of 5. Let's put these guys over here. We're dealing with a mean of 5 in our example and a standard deviation equal to 2. So approximately 99% of the area is within 3 standard deviations of the mean. So we go another standard deviation to the left, another standard deviation to the right, mu minus 3 times the standard deviation, and then mu plus 3 times the standard deviation. So mu minus 3 times the standard deviation. So mu is 5 minus 3 times 2. So this is actually going to be out at -1. Mu again is 5. 1 standard deviation is 2. Another standard deviation is 9. Another standard deviation would be 11. So we're going up by 2 every time. We're going up by the standard deviation. So 99% of our area is going to be contained between -1 and 11. Okay, so that's the recap. And trash what we have here. Okay, so just to reiterate again, except that this is a little more broken down. 68.3% is between, and we can just call this 68%. Don't worry about the 0.3. Don't worry about the 0.3. 68% is between plus or minus 1 standard deviation. Okay, well, minus 1 standard deviation to the left, plus 1 standard deviation to the right. Well, if we split that in half, 68 divided by 2, and get rid of our decimals for this, that means 34% of the data is contained between -1 standard deviation and the mean. So let me put our numbers in here. I'm going to just put 4 because it's also innocuous. So if our mean, again, is 5, so mu is 5, and standard deviation is equal to 2. And normal distributions are also described with as their mean and their standard deviation. And this is why, because your mean is going to be your center line, and your standard deviations give you, okay, well, how far to the right and left am I going? So for this case, and there's an n out here because we're normal. So for us, our normal distribution would look like this, and mean, comma, standard deviation. So the notation goes mean, comma, standard deviation. Okay, so our mean is 5. One standard deviation is 2, so plus one standard deviation, that would give us a 7 here. Plus another standard deviation, that would give us a 9. Plus another standard deviation, that would give us an 11. Okay, minus one standard deviation, that would give us a 3. Minus another standard deviation, that would give us a 1. Minus another standard deviation would give us a negative 1, because each standard deviation is worth 2, as per right here. So 34% of the data is contained between 5 and 7. 34% of the data is also contained in the interval of 5 and 3. 13.6% of the data is contained between 1 and 3. 2% of the data is between negative 1 and 1. 13% of the data between 7 and 9. 2% of the data between 9 and 11. And then if we wanted to go like between 7 and 11, we would just add these guys together. So if you want to figure out how much data is contained between each piece of a normal distribution, this is a good chart here. So I would kind of take this down as a reference for standard deviations. But that is basically it. As always, if you have a question, please just ask.